today, I'd like to introduce the scripting and debug automation capabilities that we provide with UDE. Okay, so let's get started. This is the agenda for today's webinar. And the most important thing is, I think, that I want to show you how to write a script that communicates with UDE and to perform a very small test on an application. But we need some additional information before we can start with scripting, and I'd like to show you some of these information in the next few minutes. Okay, let's get started with the UDE automation and the UDE Object Model. At first, the good news, the scripting capabilities are part of the UDE automation feature, and this automation feature is part of a standard installation of a professional UDE version. So there are no additional license fees in order to use the scripting capabilities and the UDE automation capabilities. So what is the UDE automation? So the UDE automation consists of a software API. We call it UDE Object Model, which is open and flexible. In open means everyone can use it, and flexible is you have access to almost all the debug and trace and all the features that is provided by the UDE debugger software. Almost all the things that you can do with your mouse or with your keyboard and with a interactive debug session, you can also do with scripting. So we support three types of automation. First, and I think the most important one, is external scripts. So you can use scripts to remote control the debugger session. You have also the possibility to write small internal scripts, macros, to automate some daily tasks from inside the debugger, and also to couple third-party tools, for example, test tools to the UDE, or for example, to set up a complete test environment of your embedded system, for example. So there are a lot of test tool vendors using the UDE automation interface to get connected to the debugger and to perform some tests on real hardware. The UDE automation is based on the UDE object model, and this object model is based on the Microsoft component object model, which is a product in the Windows world and a quasi-standard for communicating of Windows applications with each other, or do some scripting in the Windows world. The advantage of that is that also native C++ and .NET applications can be used together with the COM from Microsoft, and so complete applications can be developed communicating, for example, with UDE. So the advantages of this Microsoft COM approach are that we do not need any proprietary script language. So you have, there is no need to learn a new scripting language that is, for example, provided by a debug tool vendor. There is support for almost all scripting languages available that are very popular today. For example, Python, Perl, PowerShell from the Windows, JavaScript, maybe Visual Basic Script, and a lot of others. And yeah, this leads us to I think the key advantage of this approach, that almost every scripting language can be used together with UDE. And also, as said before, support for .NET applications and also support for native C++ applications. That means if you like, you can write your own application that communicates with UDE with C# or C++, for example. And this approach is also used by third-party tool vendors for tool coupling or, for example, test tools. So the object model is based on an interface description. Each component of the debugger provides interfaces, or one interface or several interfaces to the outside. And these interfaces provide methods for doing something or properties for setting or getting something. You will see later how it works. So all the objects of the debugger or the components, for example, the debugger kernel provides interfaces. The debugger kernel contains objects like the workspace, like the core debuggers, which are responsible for communicating with or handling all stuff for a multi-core system, for each core of a multi-core system, for example, run control, braking, stepping, go, to handle breakpoints, to handle the memory access. So all these things are also provided as interface methods and properties to the outside world, so you can use it by your scripts. Also, higher level functions provide interfaces like trace for profiling capabilities of UDE, code coverage, and also add-ins that can be licensed additionally to the basic license of UDE, providing support for RTOSs, etc. So the object model itself is a hierarchy of debugger objects. The main object or the starting point for each script development is always the UDE application. And the UDE application provides access hierarchically to all the other UDE objects and UDE components that can be used for automated debug session. But from here, you will always starting. To access this UDE application object, you have two possibilities. The first one is to create a new debugger instance. So you start your script and you want to use the script to start the UDE debugger. So this is done by the UDE launcher. UDE launcher is registered in the Windows registry and can be accessed very easily by its name. And the second one to get the UDE application object is the UDE running instance manager, which is which can be used to connecting a existing debugger instance. So if the UDE is already opened, then you can attach to the UDE by your script using the UDE running instance manager. And once you get the UDE application object, either by UDE launcher or by UDE running instance manager, you can use the get methods of the application object or the object properties to traverse this kind of graph here and this object tree in order to get the debugger objects that you need for your scripting or your debug automation. For example, if you want to get the debugger interface, for example, to load an application into the specific core, or to start the application on this specific core, you access this object by using several properties or functions or methods of the object model. And this is a small code template or snippet which shows you how to get the UDE debugger interface if you have a attached UDE already existing UDE session. So you get a UDE application object by asking the running instance manager for a UDE instance which is already running. Then you access the workspace, and from the workspace you get the core debugger of Core 0, for example. And then you can use the core debugger to make it go. It's very easy. So the most important thing if you want to start with scripting is how to get the help or how to get a reference of the software API. And this is very simple. In the UDE help system, you will find a chapter calling UDE Common Components, and this chapter contains all the programming, all the information about programming. And here you will find the UDE Automation Guide and Object Model reference. And from there, you get the object tree. And here you have a clickable map, if you like, in order to get the description of each object model component of each object of the debugger. So for example, the debugger interface, which is responsible for the run control, braking, go, single stepping, etc. And here you will find all the methods and properties described that you can use in your script. From here, you can click on a method or a property to get more detailed information. For example, here the debugger interface reference shows on this side here all the methods and all the functions that can be executed in a very general way, and also the properties in a very general way. But if you click on the function or click on a method, for example, read variable or access a breakpoint, then you get more detailed information. In the header, you will always find a general and UDE internal definition that can be used in C++. But more important for scripting are the code examples for different scripting languages, always provided for each function or for each property. Okay, then let's get started, and let's write a small script. And I'd like to show you the two different ways to access the UDE object and some other things else. So for this demonstration, I'd like to show you, or I'd like to use Python. We are using internally the Anaconda Python distribution together with a very nice browser application called IPython and Jupyter. notebook which allows you to interactively develop scripts using Python. So I'd like to show you in a moment how it works. On the UDE side, we have a UDE 5.2. This is the newest version that can be downloaded from our website. On the AURIX target is a TC39, and the sample that should be tested is a simple clock distributed over 3 of the 6 cores of the TC39, and the core 0 is responsible to provide a timer interrupt to the other cores, and the core 1 realizes a simple clock with all the stuff you need, hours, minutes, seconds, and tens of seconds. And the core 2 realizes a 8-bit counter, which is not important to know for this sample here. I will not use it, but we want for the core 1 simple clock provided or write a test script that will test the wraparound of seconds. So if we increment the second from 59 by 1, then we expect or we want to test if the second is set to 0, to 0, and the minutes are incremented by 1. Okay, then let's get started. This is the UDE with the application already loaded. It's an existing workspace. So you see here the code. You can see here the variables, the minutes, the seconds, tens of seconds, hours. And yeah, I'd like to at first get connected to this already existing debugger session. And this is the Jupyter notebook, which allows us to interactively develop a Python script. So in order to provide our tests or perform our tests, I will fill this script now with some code. The first is loading some important libraries provided by the Python. The most important one is this one, which is responsible for get connected to the Microsoft COM. So you remember, Microsoft COM is the base technology behind our scripting support and the UDE automation. Then you want to prepare the UDE or the connection to the UDE, and with the COM and the registered UDE running instance manager, you get the running instance manager object, and from there I can get the instance. So I can execute this. So now all the variables are initialized, and we can now get the UDE object. So the UDE object can be accessed by the method getInstance of the running instance manager. And then I would like to show you the version of the running UDE. From there, we need to get the workspace. So the workspace can be accessed by the workspace property of the UDE debugger or application object. This is the workspace file. Then we want to connect to the target. It is connected. And then here we have a wait for connecting the target with a timeout. So if we would start this script without interrupting it, then we are waiting 10 seconds for connecting, but it's already connected. So and from there, we want to get the debugger of core 0. This is provided by a workspace method, get core debugger. Okay, get some information about the core. Core 0 is a tri-core, a TC 1.6. And now we can start the application running. So, okay, we access the go method of core 0. Okay, then we start and you see, okay, the counter's running, the timer's running, and the core 0 and the core 1 is running as well. And then we want to start our test. So we know that our test is, or the clock is running on core 1. So we need the core 1 debugger. It's the same method as we have seen before. We have now access to the core 1 debugger, and then from the core 1 debugger, we access the breakpoints. So we have a method which is update seconds here, and we want to check if this method works as expected. If we increment the seconds from 95 by 1. So we need some breakpoints here. Okay, then we set the breakpoint at the beginning of this function here with the breakpoint object that we get here. We have methods to add or remove breakpoints. This method add and get result. Update breakpoint means we add a breakpoint at the function update seconds, and there are a lot of more information or more possibilities here to set a breakpoint. This is the, I'd like to show you, this is the debugger interface we already used to get the breakpoints, and from the breakpoints, breakpoints object or breakpoint debugger object, we get all the possible or the usable functions here, for example, add and get result. And this adds a breakpoint at a given breakpoint descriptor. This is the syntax of the descriptor. So in this case, we use function name, but we can also use function name plus a line offset, function name plus an address offset, or also a file name with a line, or file name with a line with an address offset, and also a address in a hexadecimal representation. Okay, so now we execute this function here, and you see, okay, breakpoint has been set. And then we need to wait. Typically, we need to wait for the halt in the application. In this case, we already halted. But if you want to save it as a Python script, then you need, and we want to run it as a whole, then you need a wait for halt function to wait for the break. And then we use a write variable function to set a test vector. And the test vector is setting the seconds to 59 and the minutes to 10 in order to make sure that you have no hours wrap around if you increment a second. Okay, execute this and you see, okay, seconds is 59 and minutes is now 10. Then we proceed to the next step in our test. We remove the breakpoint. Can be also done with remove and get result. Same syntax here. And then we set the next breakpoint at the end of the function using the syntax with the line offset here, 8 lines to line 69. Set the breakpoint. Then we make it go, hit the breakpoint again, and then we perform the test. We check the seconds, we check the minutes, and then calculate if the test is passed or failed. So the seconds are 0 now. We had the wrap around, minutes are incremented by 1, and the test passed. Then we clean up everything, remove the breakpoints, make it go, and then clean up the UDE session. Okay. So this is everything what we need to perform this little test here. I have already prepared that here with some additional wait cycles, and I'd like to show you how to run it as a Python script. I export this as a Python script. Okay. And then open command shell. Test Python. And if I execute this, then everything is done automatically. Okay. So this is the first example I'd like to show you. How to get access to a running instance of the UDE. And close the UDE, and then I'd like to show you how to get access to create a instance of UDE from scratch. And here, this is quite the same script, but the differences are that, move it to a new window, that we remove these lines here for the running instance manager and executing the UDE launcher. The UDE launcher is a component which is also registered in the Windows registry and can be accessed by its name and also by a UDE version. If you have several versions installed, then it's quite useful to use the version. But if you have only one version installed of the UDE, then you can use the UDE launcher without any version information. Then you provide some files, for example, what is the working directory, a workspace file which will be created, and a target configuration file which contains all the information about the target that should be connected. Okay, we execute that, then we execute the launcher, start and create workspace function. A UDE is automatically opened. Put it on the right side. left side. Once we get opened the UDE, we get, as known, the workspace, wait for the connected target, and then we access the Core 1 debugger. And then we want to load the application and flash the application. And the Core debugger provides a load in flash function for that. We provide the ELF file location, and then we flash the application. It's now flashed. Wait some time, start the application, and then again, all the things that we have already done with the other script, starting or getting the core debugger of Core 1, getting the breakpoints, set the breakpoint here, and go writing the variables, and then remove the breakpoint, set the next one, and then compare the results against the expected results, and test is passed. Remove the breakpoints, go, and then we clean up everything. But in this case, we do not clean the UDE object here. We use the UDE object to stop the instance of UDE and to close the UDE session completely. And then if you execute this, you have a clean desktop. Okay. So to summarize, the scripting capabilities are very generic. So we provide with UDE a generic software API that is based on Microsoft COM. So no proprietary scripting language is needed here. So the big advantage of this approach is that all scripting languages that understand COM can be used together with UDE. I showed you a Python example, but also possible is Perl, Visual Basic, JScript, or Windows PowerShell, and everything else. Important is that you start always with either a launcher object or with a running instance manager object to get access to the debugger. The launcher creates a new debugger instance and creates perhaps a new workspace, or you can load an existing workspace with that. And the running instance manager requires a already running UDE with already opened workspace. And all the debugger objects, all the debugger functions and components that can be typically or normally accessed interactively in an interactive session with UDE can also be accessed by the object model and by the object model hierarchy. And so have fun with scripting UDE, and I believe that scripting is very useful if you have daily tasks to handle and if you want to perform automatic tests. Thank you very much.